Uh, we have these last slides in the area of procedural programming. And then after that, we are going to go through one sample exam that is posted on iLearn, so you can play with that later when you have time. And after that, I'm going to speak about homework, and if there is more time, then I'm going to go more through these slides of that are in the reader in the area of procedural programming. So the first thing that we have to discuss today is recursion versus iteration. This is important because whenever you have some problem that is repetitive in its nature, so most computers are used to perform repetitive tasks, things that repeat multiple times. So in that case, you have that you can either solve the problem using iteration, loops, or recursion. So two alternative ways of solving problem are recursion and iteration. Okay, so iteration is rather frequently not a natural solution of problem. Very frequently you have that the natural solution is recursive. So the problem is that introductory programming courses always present loops before recursive functions. So people get false impression that loops are a natural way of solving problems, and that is not simply not true. And also what is not true is that iteration is easy and recursion is difficult. Opposite is true. Recursion is easy and iteration is difficult. So these are things that I'm going to try to promote today. So comparison of recursion versus iteration is based on the facts that recursive programs are always shorter and more readable and easier to understand than iterative programs. That's the first thing. They use less variables and less control structures. That is also positive. Negative is that in most cases, you have the overhead generated by manipulating stack. And this overhead is, of course, taking space and time. You have to push in the stack all local context of each function call. You have to perform function calls. So push, 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 push. And then after that, pop, pop, pop. This takes memory, this takes time. So you get simplicity of programming, but you usually are a little slower than the optimum situation. So generally, what I want to claim is that recursion is easy and iteration is difficult. Now, for those who are non-believers, try to write quicksort iteratively. And if you have ever seen iterative quicksort, it is a terribly complex program because you have in each iteration keep all these indices from here to here and not from here to here. And it is very tricky to write quicksort iteratively. If you write it recursively, you have 6 lines of code and done. Okay, so the natural way is to use in many repetitive tasks to use recursive solutions. Now, what is necessary for recursion? First, you have to have some object that can be decomposed into components, so a decomposable object. Usually, it is a list. If you have linked list, first element, second element, etc., you can chop the head, the first element, and then you get list from the second element to the last element. And then you can say, okay, process the first element, and then do the same with the tail of the list. And this is tail recursion and very simple way of solving problems. Or you have an array of objects that has specific length. So you take the last object in that array, process that last object, And then say, do the same with array that is shorter by 1 than the original array. Very, very simple. There are other forms of decomposition also. For example, bisection. If it is not linear algorithm, then bisection is cutting in half and cutting in half, and this is also decomposition. Now, you must have a boundary condition. This is necessary to end recursive calls, and you have to have language that supports multiple recursive calls. And of course, all languages today are supporting recursion, so that is not the problem. So the idea is very simple. If you have a set of objects, like objects 1, 2, 3 through n of them. So what we have to do, we take one of them, the last one. So here is the last one, process this last one. What remains is problem of size n minus 1. So problem of size n is reduced to processing of a single component plus processing problem of n minus 1 size. And this is usually extremely simple. So to show you an extremely simple case, here is array display program. So imagine that I have one array, A, that has n components. So I have a program that is displaying this array. How to display array? You can say for I equals 0, I less than n, I plus plus, and then display A of I, put a little bit space or whatever you want after that, and loop through that loop. This is iterative solution. If you want to do that in a recursive way, then you can say, you know what, I'm going first to ask, do I have something in that array? If I have something in that array, then this n is not going to be 0. If array is empty, then n is going to be 0, and I go out and do nothing. Okay, so n is the size of array, and when I empty the array, n is going to be 0. So if n is not 0, then I'm going to display the last component in the array, and this is A of n minus 1. So after I display that, put a little bit of space and say, now do the same with array that has n minus 1 component. So in this single line, you have display A of n minus 1. And that's all. So this is going to take the last element. So if I have an array that has 7 components, 0, 1, 2, 3, 4, 5, 6, it is first going to display this 6. And then here is 6. This is output window. And then it is going to display 5, 4, etc. up to the end. So this is the way how this works when I say display this array that has 7 components. It is displaying all of them in opposite order. So you can say, I dislike opposite order. I want to have it from the beginning to the end as they are written. Well, in that case, you have the same thing, but slightly different. So you have to say, I have array A that I want to display from component K to component N. Okay, so I have to have from this initial component to the last component, which is n minus 1, of course. So if K is less than N, so it is not done. Therefore, show this component A of K. Put a little bit of space, and then display everything from K plus 1 through N. So from the second to the last. Okay, so present first, and then display from second to the last. From second to the last, again, it is going to be present second, and then call program to present from the third to the last. And this is going to create this sequence here. So, of course, these are trivial examples for displaying an array, but shows the nature of recursive thinking. The good news here is that you don't have any counters, any internal variables, no loops. Just have a single line of code and say, display one component, and then after that, call the program to process the array that has everything except this process component, and that's all. So it is tail recursive or whatever you want to call that. It is very simple program. Now, what is necessary for iteration if you have iterative solution? Well, again, you need to have a decomposable object or an array of objects. That's what you have to have. Then you have to have one or more counter variables. Somebody has to count your traversal of the decomposable object. And then you have to have incrementing and testing of counter. This is necessary in each loop. And then you have to have an accumulator. Usually accumulator is an auxiliary variable that accumulates intermediate results of processing. So at the end, inside will be the final result. So let me show you an example of the use of these three things: counter variable, incrementing mechanism, and accumulator. Okay, so in the case of loop, you have components 1, 2, 3, 4, 5, 6 up to last one. And then you have counter. Counter is counting 1, 2, 3 up to 9. And then you go out and finish the processing of the problem. So here is a little example that should show that. What I want to do is to add all positive components of an array. So I have here an array 0, -1, -3, 4, -6, 5, 6. Okay, so this is an array that has 7 components. And I want to write a program that is adding all those components that are positive. So it is going to add 2 plus 4, 6, plus 6 is 12. And at the end, it should display this 12. Okay, that's the result. So how to write such program? Of course, you can do it in two ways, either iteratively or recursively, any way you want. So in the case of iterative solution, you have integer array A that has n components. And then I have to introduce two variables that are not visible in the statement of the problem. One is counter, and the other is accumulator. So I have now the loop going from 0 through n-1. So I'm going to take all elements one after the other, and we'll have an if statement inside that loop. So if this a of I is positive, it has to be taken into account. So in that case, I'm going to have accumulator equals accumulator plus A of I. So I'm going to add this component to accumulator, and we'll do that in the loop. So sometimes we'll skip this, sometimes we'll take this when this is positive. And then at the end, I return the value of accumulator. So now we have the sum of all components inside. The recursive program is this one here. So add positive components recursively, and this was add positive components iteratively. So what I'm going to do now, I'm going to say, hey, if there are no elements inside, I'm going to return 0. Okay, so if n is 0, I return 0, nothing. If there are elements inside, then I'm going to ask, is this last element, element n-1, positive or not? So if it is not positive, what I have to do in that case? I return the sum of positive components in an array that has not n components, but n-1. So that's what I have to return. In the case that this is positive, then I'm going to take this sum plus this last element. So last element plus the sum in all previous elements of this array. So it is a single line. It is very readable and understandable if the last element does exist as positive. Add that and the sum that somebody will generate for me for n-1 components. If it is negative, then omit it. It just return this function with n minus 1 components. And of course, since these two functions are applied to the same array, you get in both cases 12, which is results. So I display this too. So what is the difference between this program and this program? Well, this program here has two additional variables that you have to take into account. One is accumulator, the other is the counter. So counter has to be instantiated, has to be tested, has to be incremented. And this is adding more lines of code and more complexity. Here you have that counter is not visible, an accumulator is not visible, and still the solution is completely natural, and mechanism of recursion is creating these auxiliary variables that are not visible on the surface, and is simply solving this problem in a kind of declarative way. Now, frequently, recursion is a natural solution of problem. In such cases, it may look as the only solution of the problem. Towers of Hanoi game or quicksort are typical recursive problems that are used only recursively. But writing recursive programs is easier than writing equivalent iterative programs. Iterative programs need a lot of training with loops, and you have to know how to deal with them. So recursion is easy. Most frequently, recursive programs are slower than iterative programs because you have stack manipulation overhead, pushing everything, popping everything, passing arguments. This take some time and uses both memory and time. On the other hand, what I want to suggest in this case, that whenever you write a loop, think about equivalent recursive program. You can always write it recursively and not iteratively. On the other hand, whenever you write a recursive program, think about its iterative equivalent. What would be easier for you and shorter and simpler? And you always have to find order of time complexity. So is it O of n or O of n square or n log n, whatever is this order of complexity, find this order for recursion and for iteration. And if they are different, then of course use one that is simpler. You must never write recursive Fibonacci number generator. It should always be iterative because this is exponential algorithm versus linear algorithm. So there are situations where recursion is unacceptable, and there are cases where recursion is mandatory. Since these are two equivalent ways of solving the problem, you have to be equally familiar with both of them. And this is something that we are going to see in more examples today. Always compare iterative versus recursive solution. What is more important, saving programming effort? That means writing in an easy recursive way, or the speed up obtained using iterative program. Iterative program is usually faster, and we will see that. On the other hand, in this example that you have in a homework number 1.3, you are going to see that you can find a situation that the recursive program was a little bit faster than iterative program. So this is kind of curiosity, but usually it is not that way. So these are these slides about recursion, and now I would like to go to discuss with you this exam that we have on Monday. And so this is this sample midterm exam, which we have now. You see that on the screen. Supposedly, these slides here that are posted on 11 were taken from the previous midterm exam, but pay attention that the spring version of this class had this as face-to-face in-class exam. So it was not done online. That was the last regular exam. So this is now online version that I want to discuss because it is different from face-to-face. But it gives you the idea what is going to happen and how we are going to organize that. So the first thing, the number of problems is always 4. It is 4 because we have 4 teaching assistants, and each problem is graded by a single person. We never permit that one problem is graded by 2 people. So there are 2 different criteria. So whatever is the criterion that the grader has, it is going to be equally applied from the first to the last student in the class. So that this is fair grading that is equal for everybody. If some idea is good, it is going to get points for first student and for last student the same way. So that's why we have 4 of them. Topics are syntax, data types and data formats, procedural programming, and theoretical question if appropriate. There might be also that you have 2 procedural programming or 2 data types and formats assignments. So I will have 4 of them. Theory is difficult to arrange in the case where you have open notes and open books. So what are the rules of this exam? First, this is online exam. So online exam are always open notes and open books. So you are supposed to have open reader and open books. If you have Weber's textbook or something like that, keep it on your table. Also, your notes that you have collected, all that is okay. Also, for those of you who want to check some idea quickly on your computer, that is also perfectly okay. So midterm is open notes, open books, open your computer. All ideas, solutions, and presentations must be your own work produced during the exam time. Therefore, that is what is legal, expected, and regular. There are activities that are illegal and interpreted as cheating, and they include a couple of things. First, access to the internet to collect material that is needed for exam. This is illegal, it will be discovered, and it will be punished with negative points. Negative 50 points if you get, this is that next exam, half of your exam is lost, and this one is lost completely. So absolutely have no attempt to access anything because we are checking that very carefully and we are discovering that. So access to internet and any cut and paste of any material that is not your work produced during exam, that is illegal. So no cut and paste, please. And any form of communication with others, except the instructor, is also illegal. So these 3 things are illegal, are checked, and are punished in the way that you're going to lose the course. So don't do it. If you need any clarification, I am going to be present during exam and available through email yozo@sfsu.edu. So the same situation as in the normal face-to-face exam. If you have some question and you want to raise your hand and get the reply to that question, you can send email. I'm going to do my best to answer as fast as I can. So, but this should be something that is about clarification of the statement of the problem or something like that. Whatever is regular question in the classroom is also a regular question during online exam. Another thing, your answers are not written for computer to execute, but for graders to read and understand. So pay attention that when you write this exam, you always write that for the grader. Therefore, make it understandable and simple. Comment and explain your answers. Say, I want to do this or that. Because correct idea always gets partial credit, even if the program is not perfect. If you want, I want to do this and do it recursively, or explain your idea. And this is going to help to get maximum of points. So available time is 70 minutes. So 70 minutes will be available. I'm going to open a little before and close a little later, but it is during the class time. So this is this 70 minutes. Therefore, you are expected to come very well prepared. Now, the first thing that you should not do, don't solve problems 1, 2, 3, 4, but read all 4 of them. Find which one is the easiest for you and solve the easiest problem first. And then after that, look the rest of them, find the easiest and work on easiest. And so this is the method to collect maximum points during the exam. Don't work as people frequently do. I've seen a million times. I give exam with problems 1, 2, 3, 4. The student takes page 1 and starts solving this problem without looking what is on page 2, 3, and 4. We'll solve that later. Well, I wouldn't do it that way. I would always go with the simplest one and then 2 more complex. Prepare for exam using homework and also practice using quiz text editor. I'm going to post one sample exam, fake exam, so that you can practice that between now and Monday. Something that is having some problems that are given for homework or something, not the real exam, but something that looks as a real exam so that you can practice. Will make such fake exam available on the iLearn, and will send email that you have it. Then sample midterm exam that is presented here below was used in classroom a few semesters ago, exactly as presented. So this is the real exam, but it was in face-to-face situation. So compared with other exams, it has average difficulty. Okay. So in online environment, some questions must be omitted or modified for the online environment. You have to understand that. For example, I cannot have strong theoretical questions because everything is in books and in the reader. So I cannot ask you many theoretical questions. It is mostly problem solving. So when you go to quiz, I had questions from somebody who didn't know how to use that. So when you go to quiz to take quiz is a program inside iLearn. And then you have quiz navigation menu and timer and finish. So what you get is this screen here, where you have 4 problems. Problem number 1, 2, 3, and 4. And then you click on this problem that you want to read or solve. So you click 4 and you see problem 4, 3, you see problem 3, and then select one that is the easiest for you. So supposedly this 4 is the easiest, you click on it, it is highlighted, and then when you finish your work, you click on finish attempt. So when you finish attempt, you submit your paper and it is done. Okay. You also have timer on the screen. So it tells you what is available time. So I have 70 minutes. So this is 1 hour and 60 minutes. And this timer is counting down. So at the moment when I took this screenshot, there were 38 minutes left. So you have always available time, and don't permit that this timer cuts your work, so that you work till the last second and then it is over and you don't finish something that you wanted to say. So keep always an eye on this timer and finish before this drops to 0. We have attached that everything that is written will be saved. But again, it is better that you know when you finish and not that you are interrupted by the timer. Now, when you select this problem, what you are going to get, this screen here. So On this screen, you have the statement of the problem. This is here. Make a prologue version of the Towers of Hanoi game, whatever is the problem. Of course, this is not going to be, we are not having prologue here, but this is a sample exam. And then it tells you that you have points out of 25. Usually we try to have 25, 25 4 times, but some problems are a little more difficult, some are less difficult, so it is not that way always. It can be 20 or it can be 30 or something like that. Also, you have the sum of these problems have question A, B, and C, so they can be decomposed into small components. So when you write this field here is when you write your solution. So you write here your solution using this text editor. So iLearn gives you this text editor, nothing particularly fancy here. You have different fonts. Yeah, just use Calibri usually. You can have these lists, not much use of that. And then you can have subscripts and superscripts. So I can write C squared is A squared plus B squared like this here. So this is done. They also give you some spell checker that is inside so that you can write that properly. This is, of course, red because it is considered wrong from spelling. But this is what you have. These colors and similar things are not very important. So this is like Notepad++ or something like that, very simple text editor. Practice a little bit with that. Try to see what all these buttons are giving you as possibility, and you write your solution in this area. If it is a program, try to indent it to make it more readable, and put also comments that the grader can use to understand better what you are doing. For practice, first try to solve each problem without reading solutions. So if you go through this example, try to solve them without reading solution, measure time you need to solve the problem, make sure that it fit in 70 minutes, and then compare your solution with the official solution that is given to grader, so that you see, are you doing well or you need something else. Now, the first problem in this exam was the syntax problem, and this is one that we use for homework, I think. This is later. This is one to make exponential real number. So to make syntax of exponential real number that is having this real part and exponential part, okay? And it was given with BNF, eBNF, syntax diagram, parenthetic notation. Of course, I cannot ask you to make syntax diagrams on these exams simply because you don't have graphical editor, and to do that with Word or with hand and then take pictures and put inside, that's too complex. Keep it simple. So we are not going to have syntax diagrams, unfortunately. So in the case of BNF, you say exponential real number is sign, real, and exponential part. Real part are digits, or dot digits, digits dot, or digits dot digits. Now, what is exponential part? You have the letter E, can be uppercase or lowercase, and then you have sign, followed by digits. So this is exponential part. Digits can be one digit or one digit in front of other digits. So recursively define unsigned integer. Digit is 0 through 9, sign is plus or minus or empty, empty is empty, and that's all. In the case of eBNF, you have to say the digit is 0 through 9. If you have letters, for example, you are not supposed to put all of them from A through Z. Put A, B, C, and at the end Z, and everybody will understand that you want to put all of them. Now, what are digits? Digits have to have at least one digit. So here is this one digit, and here is the sequence of 0 or more digits. So you have to have one digit at least, and then you can append some of them. So these are digits. And sign is plus or minus. Plus or minus are terminal symbols that represent themselves to be quoted in eBNF. So exponential real number is written as sign, and then you have inside digits. or dot digits, digits dot, or digits dot digits, and after that exponential part is sign followed by digits. And that is the second problem. In this exam, there was also syntax diagram. So you can write syntax diagrams that look nice and very readable and have all these components that you immediately see what you are doing. And sometimes you have ugly and unreadable solutions like this here. You jump up, down, left, right, but both of them are correct. It is just that this one is ugly and unreadable, which is, of course, not good, but you cannot claim that there are errors here. Parenthetic notation is interesting because we can make it horizontally, which means parenthetic notation that has digits. So if you want to say what are digits, this is 0 or 1 or 9. So you have to take one of them and repeat that any number of times. Okay. So exponential random number has plus or minus optionally. And then it has these digits which are unsigned integer or dot digits, digits, dot or digits, dot digits, and then it has E, which is mandatory, and then after that, plus or minus digits. Well, if you do it that way, the question is how to do this graphically, because you cannot do that on online exam. Well, you can write it in a single line in this way. So in the case of BNF, we have comma, sorry, we have assignment, we have vertical line for or, and we have metalinguistic variables. All of them are okay for online exam. For syntax diagrams, we have circles, arrows, and rectangles. We don't have that on these exams, so it is not available. For eBNF, you have or, and you have this optional element, or you have repetitions 0 or more times. You have parentheses for grouping and terminal symbols, and you have dot at the end. So this is okay. You can have eBNF. Parenthetic notation, you can also have it if we write horizontally. So here is what you should do for parenthetic notation. You can say, I'm going to have A or B or C, and this is a selection of one of them. You must take it. But if you say A or B or C and put 3 dots, this is one or more repetitions. So it can be A, B, C, or it can be A, or A, B, C, or B, 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 C, A, whatever you want as one or more repetitions. If you put the brackets, in brackets, you have empty or A or B or C. So if you have 3 dots means the previous object repeats 0 or more times. So this here is empty, or A, or B, or C, or AB, or ABC, or whatever you want any number of times. So by using this notation, you can write exponential real number by saying digits are 0 or 9, and you can repeat that any number of times. So this is in the case of parenthetic notation. Exponential real number can be written as plus minus, and then you have here digits or dot digits or digits dot or digit dot digits, and then exponential part E plus or minus digits. And of course, these symbols 0, 1, 2, and E represent themselves. These are terminal symbols. That's what we have. Okay, so now data types and formats. Well, in this example of exam, these were more or less theoretical questions. So the first one, what is the precision of real numbers? Show the definition of precision and the formula for computing the precision of real numbers. I cannot ask you something like that because this is one slide from the reader. So will be something similar. So answer to that, precision of real number is the number of accurate significant decimal digits that can fit in mantissa of binary coded real number, which is based on sign mantissa exponent format. Okay. If the number of bits in mantissa is m, then the precision of real numbers is m times logarithm of 2, which is m times 0.3 approximately. And this is the number of significant decimal digits. The next question was, what is the range of real numbers? Definition and a formula for computing the range of real numbers. Well, the range is going from 10 to minus d to 10 to plus d, and d is the maximum decimal exponent that is taken from binary exponent that you have. And binary exponent has supposedly e bits, for example, 11. So you have that the largest value is 2 to e minus 1, and then you multiply this by log 2, and you get what is the range. Log 2 is always 0.3. So you have that this largest exponent has to be 10 to that value. So here is an example. It says you have double x, explain the binary format of x, and compute the precision and the range of x. So you need to know that in the case of double precision, mantissa is 53 bits and exponent is 11. Therefore, we have that these 53 bits have to be multiplied by logarithm of 2 to get the precision number of significant decimal digits, which is 16 approximately. And then the range, you have that exponent has 18 bits. So the largest value that you can have in exponent is 2 to 10 minus 1. 2 to 10 minus 1 is 1023. 2 to 10 is 1024. Therefore, the largest exponent is approximately 308. So the range will be from minus 10 to 308 to plus 10 to 308 approximately. And you can also write it with base 2 if you want to 1023. So this is this range. The next problem is procedural programming. Procedural programming, we have to write function sum of n that returns the sum of decimal digits of a positive integer n. So if you have that the positive integer is 123, then the sum of decimal digits will be 1 plus 2 plus 3 equals 6. So the program sum should return, when you give 123, return the value 6. So you have to decompose this into digits and then sum these digits and give the sum. And then write the function all different are in this array that has n components. All components are different, that returns 1 if all components of the positive integer array have different sums of digits. Otherwise, it has to return 0. So if you have array that is given like this, 17, 22, 33, 41, 9, this array has the sum here 8, 4, 6, 4 plus 1, 5, 9. So all of them are different sums. For example, if I had, let us say, number 13 here, then 2 plus 2 is 4, and 13, 1 plus 3 is 4, then it will be different. It will be the same. So all different program applied to this array that has 5 components should return 1. 1 because all of them are having different sums. So this is a typical little procedural program. How to solve the problem? First of all, I have to compute the sum of digits in this integer n. So what I'm going to do, I'm going to ask, is this n equal to 0? If it is equal to 0, then I'm going to return 0, and that's done. Okay. If it is not 0, then I'm going to take the last digit. Last digit is n modulo 10. This is the last digit of that number, decimal digit. And then we'll take this number and chop the last digit, which is n divided by 2, and say compute the sum of remaining digits. So last digit plus sum of remaining digits is the result. So how to compute the sum of all digits? Well, you have to return if n is 0, 0. In all other cases, last digit plus the sum of previous digits. So one line of code. You cannot write program that is shorter than one line of code. So this is perfectly okay solution. Now, I have to go and write this function whether all components of A have different sum of digits. So all different are if you have that n is less than 2, for example, one single value, all are different because there are no two that are same, I return 1, which is a flag that they are all different. In all other cases, I have to have loop going from 0 through n a minus 2. So I'm going to compare first and last, second and last, third and last, fourth and last. And if I have that some of them are equal, I immediately break the program, return 0, and it is done. Okay. However, if I have tested all this with respect to the last one, then what I have to do? Last one is not repeated in the array, so I can chop that one and say, now do this with the array that is shorter. So I have to return all different of a minus n minus 1. So now I check everything with the last and then apply this program to one array that is shorter than the initial one by 1. And this is the solution. It is having here 4 lines, here 1 line, 5, and it is done. The bad thing is that this is not particularly efficient because I'm computing this over and over again. Now, what you can do, you can go and pray that compiler is going to be smart to see this as a loop invariant and then go out and compute that and put here an auxiliary variable. Don't count on it. Is it going to do or not? Nobody knows. So you can do it yourself to avoid multiple computation of this. So you can put outside S, which is sum of these components of the last element. So to avoid multiple computation of the same expression. And then here you have a for loop, which is going from 0 through na minus 2. And then if the sum of this component equals s, you return 0. In all other cases, recursively call the same program for shorter for one position. So these are two recursive, short, readable, elegant programs, but you can do it also recursively, iteratively. Iterative solution is an alternative. So if I want to solve this iteratively, I have to compute the sum of digits of this integer n. So how to do that? First, I have to have an accumulator. Accumulator is a variable that is accumulating partial results of this problem. So I have to instantiate it with 0 initially. And then in each iteration, I have to add to that the new digit. So I have that sum is 0. And then I start my loop. And in the loop, I'm going to say sum is sum plus the last digit. The last digit is n modulo 10. So n modulo 10 is the last digit. Add this last digit to sum and repeat that as long as needed. So in next iteration, I have to have n that is without this last digit. So I divide this n by 10. So n is n divided by 10. And as long as this is not 0, I'm going to keep adding these digits. And when I exit this loop, I processed all digits from the first to the last, and I return the value of sum. And then the program here is the same as before. I have that I have two loops now because I want to compare component I with component J. So I is going from 0 to NA minus 2, and J from I plus 1 to NA minus 1. So I'm comparing 0, 1, 0, 2, 0, 3, 0, 5, 0 last. And then first, second, first, third, first, fourth, and so on and so forth. So all combinations of I and J have to be taken into account. It is quadratic algorithm, obviously. And if sum of this A of I is equal sum of A of J, returns 0. The bad news is, yes, this is short and fine, but this sum is you computed many times without reason. So you can again hope that the compiler will do miracle and put here an auxiliary variable, take this out of loop, optimize. It can happen or will not happen. So you can do it yourself if you don't trust the compiler, but don't trust compilers ever. They are always doing something that they know to do, but compilers are never smart as a programmer. So this is rule number one. You are always smarter than compiler. Therefore, use your brain and put this outside if you want as a separate variable. There are other approaches to solve this problem. You can create an auxiliary array and say this array is going to have sums of all components. And as opposed to have quadratic computation of these sums, you do that only once. But you have an auxiliary array, and then you check elements of this array. You can be also saying this is a toy problem. Nobody uses this array A. So I'm going to replace in array A all components with the sum of digits. And then after that, I'm going to process this array. I'm going to lose the previous values, but I'm going to solve the problem because that's the only what I have to do. In that case, you can have a member program. You say is element member in this array. And to do that, we have first to ask whether the array is empty, in which case you return 0, is not the member. And if you have something, you ask whether this last element is equal to element that you are testing. In that case, you return 1. In all other cases, you process this last element and you go and process the array that has n-1 components. So return the same member. So this is typical recursive program that is doing the same thing with n-1 components. On the other hand, you can do the same thing with all different. So if n is less than 2, return 1, because you have one component and all of them are different. Now, if last component is member of array that has n-1 components, you return 0. So they are not all different. There is one that is member. You must not be the member of the tail of the list. That's the point here. And return 0. In all other cases, if this one is different from others, then do the same thing with array that has n-1 components, not NA, but NA-1. So when you do that, you are going to sooner or later reach the boundary condition, NA less than 2, and will return 1 if you have no duplications. If you have duplicates, then return 0 and go out. So this is another possibility, and there are always more possibilities. All of them are and then there was a theoretical question. Describe the concept of ordinal data type and show predecessor and successor loop. So these are typical theoretical questions. You can show that, but this kind of theoretical question is just one slide from the reader. So to avoid literal copying of that, we have to invent something different for these online exams. This is for closed node exam. For open nodes, you have to have something different. So this is an example of exam, and this example is posted on iLearn. you can have it. So now let us see a little bit our homework. So we had these 3 homework assignments. One was homework assignment was syntax. The other was for data structure, data formats and type. And the third one that I naively hope that you already finished is procedural programming. So let us speak about these solutions before we have problem that is solved. And let us see what are the ideas and how to solve this, because we have procedural programming as a topic on exam, so it is good to see this. So the first assignment that we had here was a plateau program. Plateau program is one that is looking whether you have a sequence of digits that is same and what is the longest such sequence. Well, the procedural programming, again, let us expose the spirit of procedural programming, which is given by Harlan Mills here, the guy who invented software engineering. He said, programming is similar to a game of golf. The point is not getting the ball in the hole, but how many strokes it takes. And this tells you everything about procedural programming. Make program that is short and fast. So the basic idea is short and fast, short and fast, short and fast. And this is the basic thing that has to be done when we write professional programs. Dijkstra said that in the similar way. If we wish to count lines of code, we should not regard them as lines produced, but as lines spent. Spend as small number of lines as you can, not a large number of lines for problem solving. And Hoyer said that inside every well-written large program is a well-written small program. So don't pay attention only when you write 5,000 lines of code, but when you write 5 lines of code, this also has to be properly done. Regardless that the program is small, we have to be aware of performance and do it in that way. And then Strostrup, the guy who made C++, said, for many, programming has become a strange combination of unprincipled hacking and invoking other people's libraries with only the vaguest idea of what's going on. Well, this is something that is very frequent today. Try to avoid this approach as much as you can. In the previous century, people had no internet. They had only their brain. And this is the only thing that we could use. So those who learn use that, they use it today without going to invoke other people's libraries. So try to think about this. The plateau program, finding maximum sequence length, is shown here. So you have a sorted array like this one, 1, 1, 1, 2, 3, 3, 5, 6, 6, 6, 6, 7, 9. So you have to find what is the longest sequence of these numbers that are equal. So you have one subsequence and other subsequence, and then comes one that is long, that is maximum length, and another one and another one. And you have to find the program to compute the longest sequence. And of course, this longest sequence can be the last one. You have to be careful about that because you can always count how many of them you have, and then when you jump to next value, then you know what is the length of this. Pay attention that this is not a good idea because there is no jump at the end. So you have, and maybe this is the longest sequence. So be warned that this can happen. So how to solve this problem? Well, My solution is you have an array A that has NA components. And I'm going to have inside 3 counters. One is going to be for loop counter. The other is going to be the counter of the length. And this one is going to be the maximum length that I'm going to return at the end. So I'm going from the beginning to the end only once through this array. And whenever I have that A of I is different from A of I minus 1, that means I'm going from 1 through NA minus 1. So this is first and 0 component. If they are different, I'm going to say length is 1, because this is the first component of the new sequence. In all other cases, if length is greater than max length, I'm going to increment length and will put max length equals length. So I'm going to increment this each time when I discover longer sequence. And obviously, when I do that, I will get the longest sequence at the end. So here in this case, it says that the longest is 5, 1, 2, 3, 4, 5, 9s at the end. And of course, these are 1, 2, 3, 4, 5, or 4 lines of code, and this is short and understandable. This is the same thing written with different algorithm when you are going to have jump. But in that case, when you detect the jump, you have to go and say, for the last component, I will have to separately process that last component. So I have to have last length compared to max length, and then updating max length if necessary before I return that. So it is slightly longer, but works the same way. This is the same thing written in Fortran. So I want you to see how beautiful is Fortran. It has few lines of code, the loop, end of everything that starts, values that have not to be declared, and it is clean, readable, simple, elegant language. This is also the other solution written in Fortran with if, then else statement. If, then else, and if. Beautiful loop with counter. Another Fortran program. And then this was not given to you for this exam, for this case. We had elimination of 3 largest values. So you have an array of numbers, and you want to eliminate 3 largest values. So you have 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. I repeat this in my original array. And then I want to eliminate 3 largest values, which are here, 3, 4, and 5. So what I have to get as the result, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. So when you have this problem, the first thing is you have to develop the algorithm. How are you going to do it? My algorithm is very simple. I'm going to do this. I'm going to go through this array and find the largest value inside. This is trivial. To find this 5, that 5 is the largest value. So I go through this, find the largest value. When I find the largest value, I'm going to kick that largest value from the array out. And then we'll repeat that 3 times. And that's all. So find the largest value, kick it out, repeat it 3 times. Now, the program that is doing that, find the maximum value, eliminate copies of max, repeat 3 times. So what I have here, an array that has n components. Pay attention that this must be passed by reference. If you don't put this ampersand, you get 0 points in this exam, because it is not acceptable to make any mistakes in argument passing, because this is elementary thing in programming. You must never make mistake in that. So these are mistakes that are not tolerable. If you have here data, I have to specify I and j, which are counters, and I have to have this counter 3 because I'm reducing this 3 times, and the maximum value is going to be stored in max. So I'm going 3 times, k minus minus, while loop for 3 executions, and I'm going to find maximum value. For maximum is a of 0 up to the end, I plus plus. If it is greater than maximum, maximum is a of I. So I know what is the maximum. Now kick out duplicates. Ij is 0 up to n, I plus plus. If a of I is different from maximum, keep it. So a of j plus plus equals a of I. So a of I move to position j and increase j by 1. If they are not different, if they are the same, skip that and go to the other value. So you are not going to kick that out if they are different. If they are the same, then we are not going to increment this j, and this is going to be kicked out. And then it is reduced to this value j, that is the final value of this array, and repeat that 3 times. So 1, 2, 3, 4, 5 lines of code. If you have more, then you spend more. But you can say, you know what, you're going 6 times, 6 times through this array. And it is linear algorithm, of course, but you still have 6 traversals. So this is not good to have 6 traversals. You can be faster than that. And indeed you can. So question can be, is it possible to go through the array only once, and then you have these 3 maximum value, max 1, max 2, and max 3, and then it would be faster than presented solution. First time you go through array and find 3 largest, and then second time go through array and kick out all those that are equal to these 3 largest. The answer is yes. That would be a longer program, but faster. So the advantage would be slightly faster program with the same O of n runtime. However, the advantages of presented program are it is simpler than max 1, 2, 3 program. It works without modification for any number of eliminated values, because if I want to eliminate 5 values, I put here 5. So I don't have to write another program that has 5 values. It is working for any number of them. I can eliminate 1 or 2 or 3 or 4 or 5 for any number of them. Put here any value and I will eliminate that. So that is advantage. In some cases, simplicity can be worth a minor reduction of performance. So now is philosophy. Are you going to have it to be fast or to be short? If you want to be sure that it works and that it is simple and it's still linear, 5 lines of code, done. Okay. But if you want to be as fast as possible, you have to get a little more programming. So fast reduce is going to initialize low, medium, and high with 3 different values, is going to do scalar sort or put some minimum values here, whatever you want. Find 3 largest elements, so this low, medium, and high, and then eliminate duplicates of this. So you have 2 traversals of array plus initializations of low, mid, and high. This is fast reduce. Short reduce is one that finds the maximum component, eliminate duplicates, repeat 3 times. You have 6 traversals of array. 6 times go through the array. And here only 2. What is the difference in speed? So this is this little longer program that has these 3 values, but it is faster, okay? And you have also to sort that if necessary. So it is not too big. It is like 10, 15 lines of code, but it is a little less understandable. And you have here to test is between medium and high, it is between low and medium, so is this or this or this. So it is not exactly simple as the first one. Now, if I want to compare the speed of them, what I did here, so the result is this, that my short reduce program was running for 3.5 seconds, and my fast reduce for 1.86. So the difference is ratio between short and fast was 1.9 times. So almost twice is the fast program faster than the short one. Okay. And so we had either 6 traversals or two traversals. And then you have another possibility, a single pass partial sort algorithm. So this was done by Lyov Trubov, who is a genius programmer that was teaching assistant in this class. He said, I'm going to make it with a single pass. I said, my goodness. And he was doing this. He was putting this big, like sword. He was putting these largest numbers at the end of array. So if you go through array, when you find this big value, you put them at the end. And so when you finish that, you three largest are at the end, and in front of that are everything without these three largest. And then obviously you cut the array and say this is the initial part, and that's what is done with one single pass. The algorithm is not simple for understanding, and we are not going to read it here, but this is for challenge for those people who want to do that. The next thing is to display big integer. Big integer is very useful thing. I hope that you have downloaded Speedmark. Speedmark is a very, very good benchmark that I use for comparing speed of all my computers. And it is very good to know how fast is your machine. So you have Speedmark on iLearn, and hopefully you downloaded and played with that. It is a free program. Enjoy it. So what I have to do is first to take the value that I want to present, the number, and to decompose this k into digits. So what I have to do, I have to find digits in an array. So I have to take the value k and decompose that into decimal digits. And there are going to be n digits. So I have to return the value which is integer returned by reference, the number of digits. How to do that? Well, this number of digits initial is 0. And then I say digits of number of digits is k modulo 10. This is the last digit in k. So put last digits in this n digits. Increment n digits and stay in the loop as long as you have digits. So k must be k divided by 10. I reduce that by 10. And by doing this, I have 1, 2, 3, 4 lines of code. With these 4 lines, I'm creating this array of digits. Now, to display my big integers, I use a matrix of pointers. I put pointers here to all components of these digits because I want to see them all on the screen so that I can compare them and make a design of them the way I want. For example, if in this tree I dislike this at here, I can erase it and see that how it looks in a single line. So this is a good way to compare them and to see them. So I have an array of pointers, and I have 7 lines here and 10 digits, okay? And then I display my number line by line. So I'm going from 0 through 7, and then here select those values that I need to put the number. So 1, 2, 3 lines of code. So this is my 4 plus 3, 7 lines of solution. If you have more than 7 lines, you are spending too much, okay? So this is the way how you should do that. And here is how it works. You have numbers that are printed in this way. You can design it a little better or a little worse. That's not important, but it is important that you can see all of that. And then the last was iterative and recursive binary search. I did measurement with this Cygwin G++. So if you have G++, then iterative was slightly faster than recursive. You see 9.8 seconds, this was 10.5 seconds. Not much, but But when you optimize this with level optimization 3, then I get that recursive runs for 3.8 seconds and iterative runs for 4 seconds. So recursive was a little bit faster. Also, pay attention what optimization is doing, that the runtime jumped from 10 seconds to 3.8 seconds. So never compile your program with G++ without optimizing. Optimize and try to see what you are going to get and measure the speed. So that's the point here. If you do that on your laptop, this was desktop machine, this was laptop machine, you always have that this was visual C++, so you have iterative versus recursive version, and you have always that if you use debug version, then you have huge consumption of time. If you release, then you get fast execution. So this is a fast execution. If you have laptop is always slow when you work with battery because it tries to save energy. And if you have AC input, then you have that it is much faster. So this is a better thing. So this is your homework. Hopefully you finish it already and you can maybe a little bit modify it. Now, try to do that yourself. Try to do it in the way similar to I discussed here. This is good practice for procedural programming. These are programs that develop procedural programming skills, and these are necessary skills for whatever language you want to use. So that's all for today, and that's all that we have before the midterm exam on Monday. One more thing, if you need anything that I can do for you to help you, please come to office hours that are today from 1 to 2, or you can come on Friday between 1 to 2, and then there is also from 2 to 3 office hours. So I have each week 4 hours of office hours that I'm paid to help you. So use that if you need something, and if you cannot come during that period, then please send email, and I'm going to try to answer when I read your email. Any question? Peter, you raise your hand. Go ahead.
Oh, can I ask you a interview question after class?
You can come at 1.
Okay. I will go to your office hours. Thank you.
Yeah, no problem. There are office hours. Let's eat now something. 3 participants raise hand. Unmute your microphone and ask question, please. Whoever is.
Hey, are we submitting this the same way we did last time, where we just put our code into a PDF?
Yes. You put this each program with its results, put that in Word document, and then save as PDF so that the graders can read that sequentially, top down, and give you points. And this is making everybody's life easier. If you submit more, we have no money to pay too much time of graders. Graders